This video will review over the various approaches that will be necessary in order to solve half-life nuclear problems. The half-life of an element is the time that it takes for one half of that element to decay to its daughter nuclides. Each element has its own unique half-life, and you will find these on various charts. There is a half-life chart available on my website under additional information. As we look at half-life, one of the things we will look at is the number of half-lives an element has gone through. Now, if an element has gone through 0 half-lives, 100% of the element remains. With 1 half-life, half of the material remains, or 50%. 2 half-lives, 1/4 of the element remains, or 25%. 3 half-lives, 1/8, 12.5%. And so we can use this information to help calculate the amount of a specific element that can remain over a given duration of time. So notice that when we look at a half-life chart, we have time and divisions. As the divisions increase, our time increases, the amount of the matter is going to decrease. So to do half-life problems, this equation right here will be important. It is 0.5 x to the y, number of divisions, times the amount of matter. Now that sounds kind of odd, but this button right here you need to identify on your calculator. It varies per calculator brand. It can be x to the y, y to the x, caret. But what this button does is it tells us that we're going to divide an object by 5 a number of times. And this will be the amount that we start with. So let's look at an example. Let's say that we have 10 grams of strontium and it has a half-life of 29 years. So when we start off, we have 10 grams. In 29 years, which would be our first division, we would have 5 grams remaining. In 29 additional years, which would be our next division, 58 years would have passed, we would have 2.5 grams remaining. In 29 additional years, which would be a total of 87 years from the beginning, we would have 1.25 grams remaining. And so to do this, let's see if we could find out what we would have left in 4 half-lives. We would take 0.5 x to the y, 4, times 10 equals, and you should have 0.625 as your answer. Now you should try that and become familiar with the buttons and where they're located on your specific calculator. Here we have an example of gallium-68, half-life of 68.3 minutes. How much of 160 milligram sample is left after 1 half-life? Well, with 1 half-life, we would take 0.5 x to the y, 1, times 160, and we would have 80 grams left over. How much would remain after 2 half-lives? Well, after 2 half-lives, 0.5 x to the y, 2, times 160, we would have 40 grams remaining. 3 half-lives, 0.5 x to the y, 3, times 160 equals 20. Now what this equation is doing is it's telling the calculator we're going to divide 160 grams in half 3 times. Answer 20. Here we have an example of Cobalt-60 that has a half-life of 5 years. It's used for cancer treatment. If a hospital purchased a supply of 30 grams, how much would be left after 15 years? Its half-life is 5 years. 15 years has gone by. We take 15, divide it by 5, and we see that the cobalt would have divided in half 3 times. We take our 30 grams times 0.5 x to the y3, and we should have 3.75 grams remaining. Here we have an example of iron 59 that's used in medicine to diagnose circulatory disorders. The half-life is 44.5 days. How much of 2 milligrams would remain after 133.5 days? The first thing we need to do is take this time span and find out how many divisions we have gone through. So we will take 133.5, divide it by our half-life, and we see that it has divided in half 3 times. 0.5 x to the y3 times 2 milligrams, we would have 0.25 milligrams remaining. Now this is a different type of half-life problem. The half-life of polonium is 3 minutes. If you start with 20 grams, how long will it take before 1.2 grams remains? The first thing we need to do is take our 1.25 grams, divide it by 20 grams, and we get 0.0625. We will take the log of 0.0625, divide it by the log of 0.5. Now it's always the log of 0.5 because we're dealing with half-life. This tells us that we have gone through 4 divisions. Each division is 3 minutes long. We take 4 times the 3 minutes, and we should get, and this right here is wrong, it should be 12 minutes. Here we have a sample of radon. We have 150 milligrams of radon. After 11.4 days, the sample contains 18.75 milligrams of radon. Calculate the half-life. We will take our ending amount of radon, divide it by our beginning amount. That gives us 0.125. We're going to take the log of 0.125 divided by the log of 0.5, again because we have half-life. That tells us that we have gone through 3 divisions. Each division is what we're trying to determine its length. The total days we have gone through are 11.4. So we take 11.4 divided by 3, and we have a half-life for radon as 3.8 days.